Okay, so here in this video, we're going to go over the solutions to assignment 5B, which is a great assignment on reviewing all the different types of limits. It's kind of like a great summary. All right, so we're going to, in the first one, have the limit as x approaches infinity. So though infinity is not real, we are going to directly substitute it so we could see what things are looking like numerically in the scheme of things. And out towards infinity, this constant 3 won't matter. And I'm stuck with the square root of 4 of infinity squared. This 1 will not matter out towards infinity. And the square root of 4 is 2, but the square root of infinity squared is the absolute value of infinity over this minus 2 times infinity. They are both infinity to the first, so it's going to be a tie. So it's the coefficient in the top over the bottom, or negative 1. In number 2, I'm going to put in the negative infinity just so that I could see what the numbers look like. And I can't say who the denominator is yet because I have to take care of this negative exponent. So I'm going to kick that to the denominator, only that part though, and then realize that 1 over 3 to the infinity will go off to 0, and 0 minus 2 is negative 2, and this will go off to 0, and 4 plus 0 is 4. So my answer is negative 2 over 4, or negative 1/2. Um, number 3, directly substitute it, and I'll get 6 over 0, which means I can give it a positive or a negative infinity. If I pick a number like 4.01, and the numerator I'll get a positive, and in the bottom I'll also get a positive, so I'm thinking that those y's go off to infinity. In number 4, I'll replace h with 0, and I'll get root 5 minus root 5, which is 0, over 0. I'm going to multiply in this one by the conjugate, which is root of h plus 5 plus root 5 over root of h plus, root of 5 plus root of 5. I'll multiply these two out and get h plus 5. The outer and the inner will drop, minus 5, all over h times my bottom, which is that. The 5's will add to 0, while the h's will divide out. And then when I take my limit as h goes to 0, I'm left with 1 over. Now that's 0, and root 5 plus root 5 is 2 root 5. And number 5, I'm going to take the limit as x goes to negative infinity and make this as 2 plus 9 times negative infinity squared over 3 minus 5 times negative infinity. And this is the square root. Negative infinity squared is just going to be positive infinity squared. So it's going to be, that will not matter out towards infinity. The square root of 9 is 3, and the square root of infinity squared is the absolute value of infinity. A negative times a negative is a positive. So I'm going to be left with an infinity to the first over infinity to the first. It's going to be a tie, so it's the top over the bottom, which is 3/5. Over here, if I replace h with 0, I will get 5 squared is 25, minus 25 is 0 over 0. I'm just going to FOIL that out and get, not that, how about 25 plus 10h plus h squared minus 25 all over h. And the 25s will add to 0. And I still have 0 over 0, but I'm going to factor out an h from the top. And I'm going to let h go to 0, and I'll get an answer of 10. In number 7, I'm going to replace x with 2. So I'll get 2 over 0. It means I can give it a positive or a negative infinity. If I pick a number to the right of 2, like 2.01, put that in for x, I'll get a positive. And then 2 minus 2.01 is a negative, and a positive over a negative will kick that to negative infinity. Here, I think this really had intended to be an x. So therefore, that would be 3e to the negative infinity plus 9 over 2e to the negative infinity plus 7. And we need to know by now that a base bigger than 1 raised to a negative infinity power, you could think of it as, will converge to 0. So 0 plus 9 is 9, and 0 plus 7 is 7. And number 9, I'm going to do the 3, and for x, and I get 0 over 0. So I have to rewrite this absolute value function by factoring out a 3. And I'll make that plus or minus 3 times x minus 3. I'll make this the positive branch. I'll make this the negative branch. This will remain positive if x is bigger than 3, and the other condition will be if x is less than 3. I have to keep in mind that that's in the denominator of a fraction. So this function actually becomes, when these cancel out, 1/3, provided x is bigger than 3, and negative 1/3, provided x is less than 3. I want 3 from the right, so that answer will be 1/3. I'm not going to bother with 10 because it's pretty much the same idea. Number 11, if I take the limit of h goes to 0, I'm going to get 0 over 0, so I'm going to factor out h to the 5th, and I think that's what's left on the bottom, h to the 5th, and I think that's pretty good. I didn't take out the GCS, but it doesn't matter because these will divide out, and then when h goes to 0, I'm left with 3 over negative 3, which is negative 1. Over here, I'm going to replace x with negative infinity. And this will leave me with on top negative 2 to the infinity. But this will just always become a positive, times a negative will always become a negative. They are still both infinity to the first over infinity to the first, but my answer is 2/3, not negative 2/3. Because don't forget, x goes off to negative infinity. In number 13, I'm going to do a common denominator here. I'm going to times this by 7 plus h over 7 plus h, and this one by 7 over 7. So my answer will be 21 minus 21 minus 3h, all over 7 times 7 plus h times 1 over h. These 21s will add to 0. These h's will divide out. I'm left with negative 3 over 7 times 7 plus h. When I let h go to 0, I'm going to get negative 3 over 49. This is a good one to do. Replace x with negative infinity, and the absolute value of any negative infinity will become a positive. So I'm still left with an infinity to the first over infinity to the first, so it's a tie. The coefficient at the top over the bottom, 4 over 2 is 2. 15, as I approach 0, I will get 3 over 0, so I'm going to give it a positive or a negative infinity. Everything about decimals like 0.001, that's going to be a positive clearly, so I'm going to go off to positive infinity. And this is a good one to do. I'll replace x with rather big numbers here, call them infinity. And the square root of 16 is 4, and the square root of infinity squared is the absolute value of infinity. And then I'll have infinity to the first over infinity to the first. It's a tie of the top over the bottom. So negative 4/9 is my answer there. In 17, I want the limit. So I need to observe the limit as x approaches 1 from the left of g. I'll just go to this piece, which is the cosine of pi. And the cosine of pi puts me over here. The x-coordinate's negative 1. I'll take the limit as x approaches 1 from the right of g. I'll go to this piece, which is the ln of 1, which is 0. These limits are not the same from the right and the left, therefore that limit's a d and e. Down here, I'll take the limit as x approaches pi over 2 from the left of h. Substituting that in, I'll get the sine of pi over 2, and the sine of pi over 2 is 1. The y value at pi over 2, it's the y coordinate. And then I'll take the limit as x approaches pi over 2 from the right, put this in, but 2 times pi over 2 is just pi. So the cosine of pi puts me here. The x-coordinate's negative 1 times that negative is a positive. So 1 plus 2 is 3. So that limit also does not exist because the limit from the left and the right are not the same. And down here, the limit as x approaches 1, I'm going to go to the top piece. If If I do direct substitution, I am going to get 3 minus 3 on top over 1 minus 1, 0 over 0. I'm going to try factoring out the top. And this will divide out. And then I'll take my limit as x approaches 1, and I will get an answer of 4. That's where we go for the limit. And then the homework number 6, a few of these here. The vertical asymptotes. Again, to find vertical asymptotes, we have to factor, reduce, and then set your denominator equal to 0. And number 1, the nothing factors, nothing reduces. So I'm just going to set my bottom here equal to 0. I'm going to add 5, divide by 2, and x equals plus or minus 5 halves. For the horizontal asymptote, that's where I have to observe a right and a left-hand limit. Just want to see how far here. Yeah, so here, when I observe the right-hand, a positive infinity and negative infinity, I'm going to replace x with infinity. And then on top, I'll get a positive 3 times infinity. And on the bottom, I'll get 2 times an infinity. So now it becomes a tie between the top and the bottom. I'll get the coefficient of the top over the bottom, or 3 halves. But towards negative infinity, now that x up on top will become a negative 3. The bottom will stay now still a positive 2 times infinity. So it's a tie again. So it's the coefficient of the top this time, which is negative 3 over 2. So my asymptotes are y equals plus or minus 3 halves. And the next one, number 2, nothing factors and reduces. So the denominator equals 0 when x equals 1. Now again, to find horizontal asymptotes, I have to take the limit as x goes to infinity and negative infinity. So it just really becomes 2 limit problems in one. So we'll do these just like we did the other ones before. I'll replace x with infinity, and I'll get root 3 times the square root of x, or times infinity. In the bottom, I'll replace x with that infinity. I'll get infinity to the first over infinity to the first. So it's the coefficient of the top over the bottom, or negative root 3. In the negative infinity direction, you got to be careful. The top will once again stay positive, but your denominator down here, when x goes off to negative infinity, that negative times that negative will become a positive, and I will now get as an answer root 3. So there, my asymptotes are y equals plus or minus root 3. In number 3, nothing factors and reduces, so I'm just going to set my denominator equals 0. In doing so, I'll add the 2 or subtract the 2 and divide by the negative. I'll divide by 4, and 2 over 4 is 1/2. And I solve for x by taking the natural log of both sides, and I'll get that, the natural log of 1/2 equals the natural log of e to the x, which is just x by Ln properties. So x equals the natural log of 1/2. But again, horizontal asymptotes are going to trigger that I observe a limit towards infinity and negative infinity. So with x approaching infinity, I'll get e to the infinity over negative 4 to the e to the infinity. And this will be a tie, the top over the bottom. So it's going to be negative 1/4. But in that negative infinity direction again, e to the negative infinity plus 1 over 2 minus 4e to the negative infinity. Don't evaluate negative exponents. This will just go to the bottom, and 1 over e to the infinity is infinity, so 1 over big numbers is 0. So 0 plus 1 is 1. This 2, for the same reason, will be like minus 4 over e to the infinity. This will go to 0, so that'll become 1/2. So 0 plus 1 is 1, and 2 minus 0 is 2, and 1/2, and there are my horizontal asymptotes. And number 4, I'm going to set the bottom equal to 0 by subtracting 1, divide by the negative, and how will I undo that? Is Ln both sides, and the natural log of 1 is 0. Over here again, I've got to take a limit as x goes to infinity. So 3 to the infinity over minus 4 to the infinity. This exponential function, 4 to the infinity, has the larger base. So therefore, this function will kick out larger y's over 3. So therefore, you'll have bigger numbers in the denominator, which will make for 0. But once again, e to that negative infinity. If the base is bigger than 1, raised to that negative infinity power, it's going to converge to 0. And I'll get 1 over 1 or 1. And number 8, we skipped around here, I guess. I skipped number 5. Maybe it didn't scan. Let me see, since I put them on a different page. So there's that. 4. Let me just take a look here. 5 is okay. If I set the bottom equal to 0, it doesn't factor and reduce. I'm going to subtract the 1, divide out the negative, and you undo ln as base e. So x would be equal to e here in number 5 for the vertical. The horizontal asymptotes, I'm going to take the limit as x goes to infinity of f, and that's going to be infinity minus 2 over 1 minus the ln of infinity. So if I just think about this as a linear function growing like that, this is exponential growing like that, I would say at the top's going to win, so that will be a d and e. You can't go towards negative infinity for this function because you cannot take the ln of a negative. So that there would not exist in that direction. Okay, and just one more I wanted to talk about is number 8. And this one here, so this divides out with one of these. So therefore, what's left over in the denominator so far is a 1 for that. So this is x minus 1 on top is left over. Now here, I could do this right here. The top, I'm going to write that as negative x plus 3 cubed. And then I'm going to factor that negative out and make that x minus 3. Now, negative 1 cubed is a negative. So I'm going to write that as negative 1 times x minus 3 cubed all over x minus 3 to the 4th. So there is no vertical at x equals 1 because this factor in the denominator completely canceled out with one of them in the top. So there's a hole there. There's a hole at x equals 1. And then one of the 3 of these cancels out with one of these. So this factor is left over. So there's a vertical at x equals 3. As far as the horizontal goes, it's just a polynomial over a polynomial. So this would be like an x squared. This would be like a negative x cubed. So that dominating on power is like a negative x to the 5th. On the bottom, this is like an x times an x to the 4th, which is an x to the 5th. So it's a same power function on top and bottom. So it's a tie. So it's the coefficient of the top over the bottom, which is negative 1. Okay, so again, I hope that helps finding vertical and horizontal asymptotes, as well as a review there on limits.